Okay, here is warm-up number 55. Let's find the sum of the measures of the interior angles of a nonagon. So you got to know that nonagon, that means we've got 9 sides. And then the sum formula for polygons is going to be n minus 2 times 180 degrees. That's for convex polygons. Okay, so we've got the number of sides is 9. Seven times 180 is going to be 1260. So it's 1,260 degrees. Okay. All right, next up for rectangle ABCD, we're given some lengths of some segments. We're supposed to find the length of a diagonal. So what I would recommend, since there's no diagram here, let's draw our own diagram. We've got rectangle ABCD. Okay, so I'll just draw any old rectangle. That means we've got 4 right angles. And then I want to label the corners. So I can put A wherever I want, but then I should be able to walk around this and read A and pass A, B, C, then D. So I can either go this way or that way. It doesn't matter. I'm going around this way. And then now that I have that drawing in place, now I can put these segments in place. If you don't do the drawing, it might be hard to picture what AC means. Is AC a side or a diagonal? Well, in this case, AC is a diagonal. And so is BD. Okay, so now that I can see those are diagonals, well, the diagonals in a rectangle are congruent. So that means 5x minus 31 is going to equal 2x plus 11. And that will allow me to solve for x. So I'll subtract 2x to combine these x terms. And then add 31. And divide by 3. And x will come out to 14. It's really tempting to put 14 as my final answer, but it doesn't ask for x. It says find the length of a diagonal. Okay? So since both diagonals are congruent, I can use either one. I could use AC or BD. They should both come out the same. So I can use 5x minus 31 or 2x plus 11. I think I'll use 2x plus 11 just because they're smaller numbers. So I've got 2 times 14 minus 11. So 28 minus 11. And I got 39. It's the same thing I should get if I plugged in that x value into 5x minus 31. Okay, so there's the length of a diagonal. Okay, all right. Next up, find the measures of the numbered angles. So this figure, it's a quadrilateral. It's got 4 sides. It turns out it's also going to be a parallelogram, but this is a special type of parallelogram. It's a rhombus. So you got to know a little bit about the properties of parallelograms and also of a rhombus. So first off, in a parallelogram, opposite angles are congruent. So once I find angle 1, then I've got angle 4 as well. Okay. So the whole top angle and the whole bottom angle are going to be congruent. But also in a rhombus, the diagonals bisect the corner angles. So that means angles 2 and 3 would be congruent to each other. And then these two would be congruent to each other. And since opposite angles are congruent, that means all 4 of those angles are congruent. So since I know that one's 54 degrees, so is that one. But more importantly, angle 2 and angle 3 are both 54 degrees. Okay? And now that I've got, now I can take this triangle, for example, and I can find angle 4 because I've got 2 of the 3 angles in this triangle. So I can say the measure of angle 4 plus 54 degrees plus 54 degrees is going to equal 180, right? Triangle angle sum theorem says angles always add up to 180 in a triangle. Okay, so the measure of angle 4 is going to be 72 degrees. Okay. Hey, and if that one's 72, this is also 72. Okay, and we figured out angles 2 and 3 are both 54 degrees. Okay, so there they are. Okay. Got another rhombus in this last question. I'm going to approach this in a similar way. So again, the diagonals are going to bisect the corner angles. So these two angles would be congruent, and those two are going to be congruent to these two as well, because they're opposite angles in a parallelogram. Same thing here and here. Okay? So I've got angles 2 and 3 then. Those are both going to be 68 degrees. I'm just going to write it like this. Measure of angle 2 is going to be equal to measure of angle 3, and those are both equal to 68 degrees, okay? I don't have enough information to get angle 1 yet, but I can actually get angle 4 because another property of a rhombus is that the diagonals are going to be perpendicular. So that means angle 4 is going to be 90 degrees. Okay, and now I'm actually in business. So if I pull out, let's say I pull out this, this triangle up here. I know that's 90 degrees because that is, right? Those are perpendicular diagonals. So if I take that triangle out, I've already got that angle 2 was 68 degrees. And then I'm just looking for the measure of angle 1. So I'll just call this x. That's going to be angle 1, right? And all three of those angles add up to 180 degrees. So I could write an equation like that. But you can also take a little shortcut. If all three of them add up to 180, well, there's 90 degrees right there. So I've got another 90 to go. So these two are going to add up to 90, right? So in a right triangle, the two acute angles are always going to be complementary. So x plus 68 degrees is going to equal 90. And it just saves you a little bit of time. It's just a smaller equation to deal with. So that's going to be 22 degrees then. So that's the measure of angle 1 then, right? And then that is the end of the warm-up. That's all there is. See you next time.